Welcome again to question A3 for the same set of 2010. So we have a question here saying, talking about arrays, and this is a simple question of trace routing, right? Trace routing is you tracing, almost like a dry run, but here you don't care about the way the code runs. Like you don't care about the pattern it follows to get to the end point. Here you really are about what's happening to the variables as time progresses, as the function is being executed. So tracing is just, okay, let's show us what's happening to so and so while so and so is happening. Same thing with dry run, except we don't care about patterns. So looking at this function here, or looking at the question, said the array has been initialized as follows. You're given an array of size 10, 0 to 9 as index, which is inclusive of the 0, which makes it 10. Starts with 42 all the way to 0, 19, 55. So we're seeing all sorts of numbers there. It's not sorted. We have two zeros at the end. And the question goes, the function u in the code below is going to be executed with parameter v set to 7. Yeah, so this is u, this is the function. It's going to be executed at v set to 7 and w set to 70. Okay. You can choose to follow either version of the code. Trace the call of the function u7070 and state the value that is returned from the call. So the value at the end of the day, at this point, is what they're telling you to state. So you probably have to say that separately, or just make sure you let them know in a way that that is the final value from the call. So this is the table here. Let's see other questions. Write a brief summary of what the function does. So they're trying to check if you actually understand what this function does. You'd have traced it and you realize that, okay, 7070 comes in here. At the end of the day, I get something called y. What is y? Why am I getting y? Why? What's going on? That's why. Then the third one says, decide on better names for the identifier. So once you understood what this thing does, you can start giving them better names. Say, okay, I think this one should be like this. I think it should be called that, so that it will be clearer rather than use x, v. These are the abstract conventions that don't make it easy to understand this. And when writing good code, you want to put things in place that help the other programmers, or you yourself, help yourself at the same time. Understand yourself in the future, because it does happen, you come back and you don't understand what you've written. So decide on better names for the identifier, rewrite the code. So you have to write it, putting those names in place using your new names and include suitable comments. So in case some comments to like begin function works well for this, but you might want to put some other comments for what this for loop is doing or whatever. Rewrite lines 5 to 8 of either version A or B using a while loop. So you're going to take this for loop here and you're going to convert it into a while loop. That's very simple. You're just understanding that you have to bring out a few things. Just take this out, put a while here, put this condition in this bracket, leave its condition alone. Take this x++ or the increment and make sure it increments after. Code in the middle remains the same. It's just your style of converting from a for to a while loop, which we'll look at in the solution section. So thank you guys. We'll see you there. Catch up or keep up. Okay, let's look at the code and see what's actually going on behind the scene and then understand what this code is doing before we can start trace routing and things like that and what to put in place. Once you figure out what this code is doing, all these other things will become a piece of cake. So trace the call of the function u7070 and state the value that's returned from the call. This is the declaration of the function here. You have int v w, so we're passing it 7. Let's assume we call this function in main and we pass it 770. So v is swapped with 7, w is swapped with 70. Then here, new variables are created, two new variables, x and y. They're both integers. Then the function begins. First and foremost, y is set to 0. And for x equals 0, x less than v. So from 0 all the way to 7, so that'll be 8 times 0, 1, 2, 3, 4. 5, 6, 7, because it's less than or equal to v, that would have counted 8 times. Then increment x++. But for this case of counting from 0 to 7, if z of x, so the z you are looking at here is this array. Now look at the array here, z. So if z of x, which is z of the index, whatever index x is on, so for the first one to be at 0, so if z of 0 is greater than w, which is 70, right, increment y by 1. So because y is 0, so add 1 to y. Then do this loop again. Now x will be 1, right? So that moved to 1, right? And then to be if 19 is greater than 70, increment y by 1. Then it will move to 2. If 55 is greater than 70, increment this all the way down. Now, what does this thing seem like it's looking for? Because when it gets to 90, which is here, when z of 3 is checked, and to see 90, it will be greater than w, which is 70, and to increment this by 1. So this simply tells us that this function is trying to find all the values between a certain part of the array from 0 all the way here, from 0 to 7 of this array that is greater than 70. So all the numbers greater than 70 is what we're trying to count. So this is a count, a greater than 70 count, or a greater than count. So we're checking what's greater than 70 here. This is. So our y++ at the end of the day should give us 3, going from 0, 1, 2, 3. We know what this function does, which is what we can do in this brief summary. So I'm going to skip that. You're going to say that yourself because it's subjective, whatever you want to put down. But the idea is that it should make sense. So you are saying this function's job is to traverse an array, right, by taking in parameter 1 that shows us what part of the array we want to go up to. And then the second parameter tells us what we are supposed to find in the array that is greater than the input. And then we are supposed to return the number of times that those items that are greater than, the second parameter are found. So, decide on better variable names. I'm just going to change the names and tell you what the names I think will be suitable for this is. I'm not going to rewrite the code. It's going to take some time. Rewrite lines 5 to 8. So I'm going to switch this, swap it, move it to a while loop. And then we're good to go. So let's trace the call of this in real time. Okay, tracing the call of this function. What do we need? What do we want to talk about that is changing? We know we know v, these things stay the same all through. So x is going to be changing at one point in the for loop. Y is going to be changing at one point too. And also z of x is going to be changing at one point. W stays constant, right? Because W is 70. So it's going to be comparing this against this. So we want to bring this out and this out. We want to talk about this condition here. Still, is it the same thing? Does it continue? Because we want to talk about what's happening with this for loop. So here x is one thing. Then it checks is this condition true. If it's true, it does this condition. If the condition is true, it executes this line of code. And then it comes back here to increment. So you can see all the steps that are necessary. I'm about to show that in the table. So I have a table with cells or columns for x, for y, for x is definitely 0. It's initialized in the for loop here. So taking care of that. For this condition, is it true or false? Then for this condition, does it actually happen? Well, it happens. Since it happens, x is going to be changing based on this. So I might not need a column for x plus plus. I need a column for this, so if it's true or false. And I need a column for this. I don't need the column for this, but at the end of the day, this will be returned, whatever it is that this one has become. So this x, y, condition, this. We don't need this. Let's go into our bamboo sheet and see what's going on. So I removed y from here and brought it here because it makes a lot of sense to see what's happening along the way with respect to y, since it's y we are returning. So most times try and put what you are returning at the last part of your table. It helps a lot to make it make sense because we are seeing what's happening every time that output or that value is changing. So we can tell at the end of the day, okay, the last value at the certain section of our table, which is towards the end, is what we're expecting to see returned from the table. So let's get back to join. This is v, right? W, x, condition in the for loop, this condition in the if statement, and then what's happening to y. So at first, v is what? V is 7. Probably will remain 7 or true. W is x is 0 in the beginning of the for loop. So yeah, x less than or equal to v true. Z of x in this place, z of x will be z of 0. So that's 42. So the next question is 42. Is it greater than 70? If it is true, increment y. But since it's not true, y remains at 0. Then move on to next, because we're done with this for loop. Start again. This one remains at 770. X will now be 1. It will be true, right, all the way. This one will now be what? 19. Is 19 greater than 70? No. So therefore, y remains at 0. Again, 770. Now, these ones are here for the sake of this v here and this w here. So it's easy to tell what v is at any point in time. So 0, 1, x is now, this one has incremented because this one's incremented by 1. X is now 2. This is true. And this one is 55 because z of x is 55. Then we check again. 55 greater than 70. Oh no. So y doesn't increment. 773 true, right? 90. Oh wow. 90 is greater than 70. Since it is true, this one increments to 1. Okay, so the question is it greater? 81 greater than 70 is true, increment this. 76 greater than 70 is true, increment this. 12 greater than 70 is not true, leave this at 3. Then 49 greater than 70 is not true, leave this at 3. So at the end of the day, 3 is what will be returned from our function. Because if we check here, it says return y. So once it's done with this, returns y, right? So once it's done, once it comes in here, it will increment x one more time, right? And check against the condition, which will now be false. And so therefore, it will stop running this for loop and it will return straight to y and we'll have our answer. So that's why I said it will run one more time. So what I'll do is add an extra line here saying it's still 7, it's still 70, x is now 8, this is now 4, so it doesn't run, it doesn't check for this, it doesn't check for this, and just y continues to remain at 3, which will be returned from our function. Yeah, so that's that. That's my trace. Thank you guys. So the next question, which will be left to your discretion, is this. We'll just switch out the names for these things here. So what will I put in place to change this, to make them to make it sensible? I'll say V. Let V be. So V is the range, right? So I could say V is range. So I could create array range or range of array. So I could use, then W is, let's say W is my key that I'm trying to find. I'll call it key that will help me find the greater than. I'll call the function itself U. So greater than count. Okay, that gives that. I'll say X is my count. So X will be the count. So most times that's the counter, right? So X is the counter. Yeah, I'll call X the counter. Then V, well, V is range of array. So size, yeah, range of array. What else? Z, I'll call Z the array itself. So I'll say array. So you can try and keep a consistent naming convention, right? So I'm using camel case range. This should be capital letter of array. This should be small letter of K. This should be greater than small letters. This should be counter small letter array. Keep a similar convention. If you're using capital letter, use capital letter all through. Things like that. Just make sure you stick to a certain condition convention. It helps with your outline. Okay, so we have Z. What else is there we have not changed? W has been changed. Yeah, so we have those things. I think we've changed everything. Then our comments will be, what comments will I put in place? Begin the function. So for loop to loop through. So the for loop I'll say is to loop through the range. I'll put a comment here. Simple 2 lines. This one is to check which one is greater than 70. And this one I'll put a comment here to say to check numbers in array greater than key and to increment count. But I'll put this on a new line followed by braces. So I'll put braces here. If I was to rewrite it, put this on a new line. Y++, then end that brace followed by this last brace here. So I'll do that and then keep this one its own comment to say count number of times Y is found and I return Y. So that's that. Comment here for the for loop. That's to loop through the array. Comment here. This is to check condition that the value in the array is greater than your key, and this is to count, to increment the count that lets us know how many times greater values were found. So that's that for this. So we can go on. Rewrite lines 5 to 8 of either version A or B using a while loop instead of a for loop. Now, this is a simple question. The idea behind writing while loops and for loops is as simple as you knowing what they have that is similar. So a for loop, like we said, is always about a counter. So int I equals 0, probably whatever variable you choose, I less than something. So less than something or equal to, this is the condition, right? And then what else? Then you have your increment, I++. So this is the counter, this is your condition, this is your increment. And then here is your line of code. Now, a while loop, on the other hand, since it is based on condition, you want to put what is missing here in a while loop to make it act like a for loop. So what do? This counter, let it be outside of the while loop. So you can put a counter int I equals 0. Then you write your condition, your while loop with a condition, which is this condition here. So you're going to put this here. And then you're going to have the increment happen inside the while loop. So it will be I++. So here you also have the same lines of code like before. So converting what we saw here, right, what we've seen in this for loop to a while loop will be as simple as just taking everything that we've seen and then rewriting it. So let me just see if I can rewrite that now. For x equals 0, x less than or equal to v, x++, if condition z of x greater than w, then now I like to ident mine differently. Do y++. So this is the for loop we're supposed to convert into a while loop. This brace is for this brace. This brace is for, sorry, I have 2 braces, which is wrong. And this brace shouldn't be here. That's why it's good to check that you have braces that match. Opening braces should match closing braces all the time. So yeah, we have our code ready to go. Now I'm supposed to convert this into a while loop. What do? I simply just take out this for, first and foremost. Take out this, then take out this also, but not to take them out completely, just to put them in new places so they can perform the same thing. So I bracket my condition and I put a while loop behind it. Here we have a while loop, right? While condition true, do this. Then we have to set the count. Where are we starting from? So we can do it started from 0, so int x equals 0, that's our count, followed by the while loop, followed by the ending. So the ending of the while loop, once the while loop is done with the line of code, we want to make sure that x increments. So it will be x what? Plus. And this is simply what you need to do to convert the code from a for loop that it is in this section to a while loop that it is now in this section. So that's that for this. So We are good to go. We've gotten it. Let's move on to the next question. This one, what's this? Choose either program A or program B, and then find and copy out an example of each of the following: a reserved word, a variable. This is a very simple one. This is a very, very simple one. And this is probably what everybody will try and solve. We'll check the exam reports to see what they're talking about. So now we're looking at question 8.3, the reports for question 8.3, and here it says, okay, this is the question itself. Let's go down. Answer pointers. Here we have a table that looks like our table. Or did they stop at number 7? I went a step further into 8 because I was showing us what's going on in between the conditions for the for loop, which is what I have here. So I have this going on, right? I have Y at the end of the table, which sits in nicely with what they've done. Then I have this last one because here the for loop execute one last time to check the condition before it breaks out of the whole loop. So it doesn't happen here. It doesn't do anything inside the loop. And then, okay, so I'm showing everything that's happening because I added this. If you don't add this, you can just decide not to show us the last thing. And then, what else? Let's see again. The function use searches the array between index 0 and v7 and counts how many elements have a value greater than 70. Yeah, so this is exactly what the array does, saying it in their own simple terms. The third one says looking for names that suggest the meaning of the variables in the program. So they're giving names to meaningful things. They use U to be count, GT, V to be upper, W to be minimum, X to be the index, Y to be the count. I used V to be the range of the array, W to be the key I'm looking for, U to be greater than count. So X in my count as in my array. Well, I think I got chosen a better name for key. Yeah, because here this is the minimum actually. The minimum number that you have to be above before you can be added to what's been counted. Okay, so the next one says you write the code using meaningful names. So yeah, you take those names you've written and you rewrite them. Then the next one, rewriting that using a loop. Here we have that while index less than or equal to upper. So they actually put the meaningful names back, but I didn't do that. But I don't think that counts for less. They didn't tell me to do that. Then doing this index plus plus and having the index outside. This is exactly what I did. This is for the second one, but this is what we're looking at, which is basically what it's here. You have your counter outside. You have your while the condition is happening, while it is true. Continue to do this over and over again. And I've tried to format mine a little bit more appropriately than they did. And then I have my increments going on here. And then the while continues to execute until the condition changes and then it breaks out. So that's about that for that. Then let's look at the last part of it, which says, this is a popular question. Getting the right answer is only worth half the marks. It was puzzling to find candidates answering parts B, C, and D, while leaving part A blank. So many people don't know how to trace route, and I bet you these questions come out too often, like tracing all over the place. A few candidates had, for example, Z42, Z19 in their traces, showing a confusion between the subscript index of an array and the content of that subscript index. So the subscript of an array is the Z itself. The index is the inner values. This is the subscript, is the name of the array, and then this is the index of the array. Saying Z42 means you're looking at the array Z with an index of 42, for which our array doesn't reach. Our array stops at 9 in index. So 42 is out of bounds, and that will be an error. Okay, precision was required. There are 6 points to be made. The function U searches the array Z between 0 and V and counts how many elements have a greater than W value. So yeah, this is the precision that we are talking about. Array is one thing, count is one thing, greater than W is another thing. The function does not sum the values in the array. Nope. The function does not find the maximum value in the array. Nope. The function does not find the sum of the values in Z that are bigger than 70. It's basically trying to count how many values in the array are greater than what was given to it, which in this case is 70. When choosing new names, some candidates only give a new name for the function or for the function and parameters, but not local variables. Inside the function, you want to name the variables you find it. Those are called local variables. And you want to name those ones too, because that is what they asked of you. Give better names to the variables that you find in the function. Some of the new names given were no better than the original name, e.g. param1, param2, Now, this is still arbitrary. Param1, parameter 1, parameter 2. Give them appropriate names. Some candidates named the parameters in pair, e.g. main, max, or start, end. These were not accepted as it showed a misunderstanding of the purpose of the parameters. The purpose of the renaming is to help anybody who looks at your code understand with the names what your code is about. Comments were often several paragraphs of separated text. What was required was in program comments. So in program comments, just is like a single line comment where you use a double slash, right? Marks were not given for superficial comments like start of function, start of loop, for end of function. This is like talking too much. You're talking about the start of a function. Yeah, it's the start of a function, definitely. Talking about the end of a loop. It's the end of a loop, definitely. We want to see what the algorithm is doing and tell us what a part of code is doing. So I could say that for loop, instead of saying start of loop, I said the loop's job, right? This loop is to iterate through the array. That's what I'm saying. And then in the second part, I'm saying the if statement, the if statement is to help us check which condition is greater than. So I'm trying to explain my code, not to say things that we already know, things that are supposed to happen. You're not supposed to do that. This part was badly done, right? Some candidates merely changed the word for to while, hoping that it would be enough. It was not. Many others put a reasonable condition after the while, but then forgot to add in the counting code, index 0. So you have to put this at the beginning and this one at the end of your code. Those that included the counting often put in the wrong place, e.g. index 0 inside the loop or index plus plus outside the loop. So done with question 3, we'll move on to question 4. Thank you for sticking around. See ya in the next video. Bye.